Hello everyone, my name is Mark. Welcome to my Calc 3 videos. And today we're going to talk about length of curve and curvature. So, the first question I have for you is, I want to kind of go back and review on the topic of motion in space. So, let's say I give you R of t is a position vector, right? Then what is the physical quantity does the arc length formula produce, right? We have already learned this in the previous video, in the previous lecture, right? So the physical quantity of this arc length is called the distance traveled. Right. So they are pretty much the same thing, but instead of calling it distance traveled in a physical meaning, we are just generalizing it as an arc length. So the second question is, so this is about parametrization. This is a parametrization question. So let's say we are on a highway, right? This is not to the danger zone, I promise, right? So we're departing at 9 a.m., right? And then we are departing on the highway at milestone 0, right? Our speed is recorded throughout the journey. And then there's also numerous milestones, right? So we have milestone 1, milestone 2, that indicates 1 mile, 2 mile along the highway, right? What are the methods that we can use to express our location, right? So so one way we can describe our location is, as we have learned before, right? We can use the distance travel formula, right? That requires your speed and the time. Right, so that's the method that we have been learned about and we're familiar with. But we can also, because we have these milestones along the way, right? We can also just use these milestones to describe our location, right? Let's say highway, highway 65, right? I'm at milestone 20, let's say, right? So if I have an accident, if I run into an accident on let's say near the 20 milestone on the highway 65, then whoever I need to call them, then the emergency services or the police would know that, hey, this guy ran into an accident at the 20 milestone on highway 65, so they know exactly where to get to rescue you. So the second way we can describe our location is just using what I call the arc length. Right, so the milestone is essentially the expression of the distance, which is the arc length, right? So how do you know whether a function uses arc length as a parameter? Right, so now we have discussed two ways to parameterize this curve. So how do you know which one is which, right? If it's not parameterizing using an arc length as a parameter, how can you turn this function into using arc length as a parameter, right? The arc length parameter we call it S. So I'm gonna return to my handy notes right here, so length of curve and curvature, right? So each video I have a lecture notes. I don't usually show you, but I would show you whenever it's necessary, right? So here you have the arc length equation. I think you already know, and then so this is I was talking about, right? So this is parametrization with respect to arc length instead of time, right? So something I need to clarify here is that t is just a variable, right? We often say t is time, right? Because it quote unquote makes sense in our it makes sense in my monkey brain. I don't know about you, but at the end of the day, it's just an alphabet, right? It's just a parameterization variable. A lot of times it is analogous to time, but it doesn't have to be. So this is the case that it does not mean time. So, so the one thing that we can do. So first thing that we need to identify whether a function parameterizes with respect to arc length is that we need to so let's say we have this vector, position vector right here. We can find the first derivative, which is a velocity, quote unquote velocity, and then we can find the magnitude of that velocity, and then as long as it's not a constant, right? So we have 2t times 13, right? T is a variable, you can change its value, so that means the magnitude of this first derivative is not a constant of 1. So because it's not a constant of 1, then this is not a parameter with respect to the arc length, okay? So this is the way to tell whether it's parameterized with respect to arc length. If it's not, then how can we turn this into parameterizing with arc length? So what we can do is, well, we just found out our velocity function, right? So we can integrate this velocity function. Actually, never mind. I think this should be, yeah. I think this is, instead of calling it velocity, I think you should just call it speed, right? So speed is the magnitude of velocity. Speed function. So as of t, right, so we know that 2t times 13, right, we're replacing t with another variable u, right? U is just another variable. We integrate it, we get this scalar function, and then so we have s equals to 13 times t squared minus 1. So we're going to rearrange this equation to solve for t, right? Since s is this, so we can rearrange it and then get t equals to this, just playing with algebra here. And then finally, you can substitute this t in the original r of t, right? So we have the t right here, and we also have the original r of t right here, right? So we're going to just replace this t with the expression that we have right here, and then we end up with this vector. And this vector is the same vector as the original position vector, but now we have a different parameter, which is the arc length s. I hope that makes sense a little bit. If you don't really understand it, you can go back to these same notes PDF and follow through what I have written step by step. But we gotta move on. So, right, so curvature formulas, right? So this one is quite simple. You just need to memorize these two formulas as you enter your exam. There's not much of a sort of a trick to it. So here you go. Right. So this is the first curvature formula. This is what I would use the most frequent because I don't have to worry about this nasty cross product that I have right here. And then so you know that this big T is what we have learned before, right? It's the unit tangent vector. The unit tangent vector, the definition is provided right here. So so you just need to memorize these two. You can take a screenshot if you want, write it down your notes, but we can move on to the first question. All right, the first question I have for you is find the length of the curve and giving you the vector function, right? So I think everybody understands that this is a length of curve question, right? I think this is, again, a very easy type of question to identify by just looking at the keywords right here. But again, I must remind you that as we continue in our learning, you will encounter a lot. You know, your type of question you'll be facing increases a lot as we go on. So you need to be able to quickly identify these type of questions. Okay. So let me go ahead and open the one pager and open my solution. Let me just go ahead and stack them like this. So, okay, so, right, so the length of curve, right? So this is the arc length problem, right? And then you have the length of curve. So we're just gonna go ahead and highlight that and then proceed with our first step. So the first step is as easy as it seems. I want you to identify the r of t that we're dealing at, and then also the time interval which the t belongs to. So r of t is, I'm just going to rewrite the question right here, is t squared plus t squared t cubed over 3 and then 7, okay? And then t belongs to, this is the important part, t belongs to 0 and square root of 12, okay? So that's your step 1. And the step 2 is to find the derivative of r of t. So r prime of t equals to 2t t squared 0. Easy enough. And then step 3 is going to find the r prime of t's magnitude. R prime of t magnitude equals to 2t squared plus t squared equals to 4t squared plus t to the 4th. Okay? And then step 4, right? We're just going to jump straight into the formula. So 4 is L equals to A and B. A and B is the time interval, right? So that we just have found out right here. So that is 0 to square root of 12. And then the integrand that we're integrating is right here. And then we're gonna have the dt, right? So we are using this part of the equation. I mean, these two are pretty much the same. It's just vt equals to r prime of t. So, well, people will wonder, hold on a second, Mark, how do you actually solve this integral, right? This seems crazy to solve. Well, this is where I will need to remind you that don't forget about your Calc 1 and Calc 2 integration skills, okay? So, instead of writing the integrand as this way, why don't we go ahead and take out the square terms, right? T squared. So we're going to take it out, extract it. T squared becomes t, 4 plus t squared, right? Or t squared plus 4. Doesn't really matter. So we're going to rewrite this integral as this. I hope you see where I'm getting at. Delete. Come on. Why don't you paste it? Okay. So we are going to utilize what we have learned in Calc 1 and Calc 2, something called U substitution. We're going to let U be equals to t squared plus 4. Okay? And then du equals to 2t dt, and then dt, which is going to rearrange this formula, equals to du over 2t. Okay? So we're going to substitute this back into our integral. So for people who likes to, for me, I would like to go back to, for some people, they like to find the new bounds of the new u substitution variable u. I don't do that. I like to save some hassles from me, and I like to return to my original variables. So when I put this, I don't put the integration bounds in because they no longer represent the bounds of u. So t, 4t squared, 4 plus t squared, and then we're going to substitute this dt with what we have right here, du dt, sorry, not dt, du 2t cross equals to 1/2, and then we're going to substitute this with u. So u 1/2 du integral. This will give us 1/2 3 over 2 over 3 u 3 over 2, and then we can cancel the 2 out. What we are going to end up is 1 cube or 1 over 3 t squared, right? I'm substituting this u, right? This u back in, t squared plus 4, 3 over 2, 0, right? Returning to the original variable, square root of 12 equals to 1 cubic, oh sorry, 1 over 3. 12 plus 4, 3 over 2 minus 4, 3 over 2. Okay, this will give us 1 over 3 16 3 over 2 minus 4 3 over 2. Okay, and this will give us, right, so people was like, what is 3 over 2's power of 16? Well, I don't usually think about that too hard, right? I know that if this is in the denominator, if the 2 is in the denominator, that is square root, right? That's the square root of 2. This is 1 over 3, so this equation will become 1 over 3 is, well, square root of 16 is 4, so I'm going to put 4 right here, and to the cubic. And then minus, well, square root of 2, square root of 4 is 2. So 2 to the 3 power, and then this will give us 1 over 3, 64 minus 8 equals to 56 over 3. And this is the correct answer of this problem. Okay, so let's review this really quickly. Switch your orientation, right? So this is a pretty straightforward problem, right? We find the t, we take the time derivative, and we find the magnitude, and we just plug in the equation and integrate. So that's pretty straightforward. And then let me go ahead and show you the next set of questions. So find the curvature of the curve as such at t equals to pi over 4. Okay, so I think everybody can understand that this is a curvature problem because, well, again, this question told you, right? Curvature problem. And then the problem type is just curvature, and the keyword is well, the name itself. So to solve this problem, we are going to start with finding the r prime of t, right? I hope you already know where the r of t is. It's usually given. So the first step is to find r prime of t. So we're going to start with r of t. That is 2 sine t 1, and then 2 cosine of t. Okay, let me just show you again. It's right here. And then r prime of t equals to 2 cosine of t, 0, negative 2 sine t. Easy enough. And then we're also going to find the magnitude of r prime of t equals to, well, I think everyone understand that this is cosine, this is sine, and this is your r. So the magnitude of this is just 2. Right? So the magnitude of that is just r, the value of r. Well, second step is, well, we're going to start with finding the unit tangent vector. So unit tangent vector, right? So we're going to start with well, we know r prime of t, which is right here. We also know the r prime of t, the magnitude is right here. So we can find the unit tangent vector really easy by just plug it in, which is 1/2 of this vector, right, equals to, taking the 2 apart, we're canceling the 2, and then we're going to end up like that. Easy enough. And then, so well, the reason why we find the unit tangent vector is that we're going to take the derivative of t prime so that we can find the magnitude of t prime. So that's step 3. So t prime equals to negative sine t 0 and then negative cosine of t. Okay? And then the magnitude of that is just 1. Right? I think that's easy enough to understand. Therefore, step 4, we finally, right, so we kind of zoom out a little bit, right? We found the magnitude of prime of t, and we also find the magnitude of big T, right? The unit tangent vector is the magnitude. So we construct the kappa, I think it's called kappa. So that's the curvature equation. So we are going to just have, well, 1 over 2. And that's the curvature for the curve for all values of t, because t is not part of the equation. We don't need to substitute the t equals to pi over 4n. So the correct answer for this question is just C. Right, so these two, and I think this is also pretty straightforward type of questions, right? You just need to memorize the equation, and then you can find the component that's making up the equation, and then you can finally assemble the parts and get the answer. So this is all I have for you on 14.4 and to 5, length of curve and curvature. Thank you very much for watching. I hope you learned something. I hope you can memorize these solving process, right, into your brain, so that you can utilize them every time you see a type of questions like this, and come right to the solution as quickly as we can. So thank you very much again, and I will see you in the next video.